So I'm not used to doing this introduction in English because usually this podcast is in Japanese. So bear with me if it's like a lot of ums and ers. But this is the UIT Inside podcast. UIT is the front-end organization at LY Corporation, which is a Japanese company, and our major products are the Line Messenger, which is the leading messenger in Japan, and then Yahoo Japan, which is the search engine Yahoo, but the Japanese version of that. And today I'm really, really excited because we have the most amazing guest ever on. We have Dan Abramov on the podcast. Dan, can you introduce yourself?
Hi, thank you. My name is Dan. I guess I used to work on React, so that's how you might have seen my avatar on GitHub sometimes. And then I used to work at Bluesky, and now I'm working part-time on the Next.js team at Vercel.
And you work for Vercel Japan, is that right?
That's the plan. So currently I'm still in UK, but I submitted the visa. Visa documents. So we'll see how that comes through. But the plan is to relocate to Japan possibly at the end of the year.
That would be so cool. And you're always welcome at our office. By the way,
Thank
the
you.
visa documents can take quite some time. I applied for permanent residency in Japan, and I applied 16 months ago. So.
Oh, okay.
But I hope you can get fast tracked.
Yeah, hope so.
Yeah, and obviously I had you introduce yourself, but you don't really need an introduction. When I told my colleagues that you were gonna come on the show, they were all so excited. So you're not just famous in the English speaking world, but every Japanese developer also knows you.
I thought people already kind of, because I disappeared a little bit from the scene. I think there's a new generation who I haven't really talked too much.
Yeah, I guess there's a new generation as well, but you're still the legend, I guess. So we had a meeting last week on Thursday, and I was like, yeah, Dan is coming on, and they all spammed the chat with emojis because they were so excited. And I've never had that happen with a guest coming on before.
Oh, cool. Well, appreciate it.
But today we're not talking about React. We're actually here to talk about something completely different, which is
supposedly stands for authenticated transfer. So I think that's kind of the formal name. I think really the reason is because it looks like @ symbol, and that you use in usernames, and it's a protocol that has to do with identity. So it's kind of like when you say my Instagram handle is it's an internet protocol instead of something specific to a company.
Okay, so you and I are both on Bluesky, so I think we have quite a bit of contact with the ATProto, but the majority of Japanese developers is still stuck on Twitter or X, and they might have never heard of ATProto. Can you just give us the 100 feet bird's eye view of the protocol? What is that?
Yeah, it's very tricky to answer because a good protocol stays invisible, in the sense that it's a way to build social apps, not necessarily social, but I guess that's an easier maybe area to focus on. It's a new way to build social apps where that was originally developed by Bluesky, the company that you might know as a Twitter clone product, but really originally they were supposed to do that with Twitter itself. It's just that Twitter broke the contract with them. But the thing that they originally wanted to build is a generic kind of universal internet protocol that I've tried to describe it in different ways. I don't know which one resonates. It's different audiences understand it differently. One way I would describe it to web developers is that it tries to extract a identity layer for the web. So it's kind of each app has its own login, and then for social apps, you can create different kinds of things in the app, but they kind of stay within that app, right? Like if I write an answer on Stack Overflow, it's kind of stuck inside Stack Overflow. If I write a comment on GitHub, it's kind of stuck inside GitHub, in the sense that I own what I made using their products. And then if this company start changing, in ways really maybe you can abandon them, but then you've invested so much effort and so much content into these like closed spaces that they control. And the idea of ATProto, or shorter ATProto, is to kind of lift that out so that everything works more like files, I would say. So, when I like post on Bluesky, I'm not actually putting stuff into the Bluesky app, although it looks like this, right? Like if you just use it, it kind of looks like it kind of looks like Twitter. Or if you use Tangled, which is ATProto, like GitHub alternative, it kind of looks like GitHub. But what happens behind the scenes is actually, it's almost like I have a folder somewhere in the cloud that has data from all of these apps as JSON. So it's kind of like everything is stored as JSON in this new layer of the web that is kind of app agnostic. It's not controlled by like one company necessarily, right? You can like host this folder with different providers. You can host it yourself. It's really cheap, but it's like app agnostic. And as a result, anyone can start a competitor to one of these services or one of these apps with all existing data already there and kind of already interoperable with existing apps. So like if somebody wants to start a competitor to Bluesky, and this actually happened, like there's a like Blacksky, which is like it has different moderation policies and so on, but it's completely interoperable with the Bluesky app, even though it doesn't use the Bluesky API. So that is the big thing. It's like every app on ATProto, it's kind of like a shared API where you don't need to provide an API as the app author, because every app, like all apps, kind of just write to these files, so to speak, like this JSON. So it's got like a common way it's like a way for apps to, in a sense, talk to each other, or like show content from each other and augment each other without actually talking to each other. So without exposing an API, because the protocol itself is kind of the API. So that's like there's a few other ways like I like to explain it, but I think that's kind of the big idea, is just like freeing the stuff that we create, from lifting it out of apps and making it live on an independent layer that we actually control as users, so that everything we create kind of is more like files, I think, under the hood, but with
And
the same normal user experience, like for like the app user.
and you actually have a great blog post on this. You have like a social file system as the blog post. It's on your blog overreacted. And it sort of like talks about what you like. You just did the perfect summary, actually. We can just end the podcast here. But I think we want to dive a bit deeper. And since this podcast is mostly for web developers, I prepared a little ambush for you. So ATProto is a protocol, and web developers usually are familiar with the HTTP protocol.
Yeah.
So I sort of wanted to go up the stack layer by layer and like see where they differ, what ATProto offers on top of HTTP, how they even build on each other. And this might be like a check of your HTTP knowledge, but we'll just keep it real simple and easy. And so the layer 0 of HTTP is, what is HTTP even for? It would be a like communication standard between clients and servers. And you already hinted at this, but like, what is the layer 0? What is it for behind?
Kind of builds on top of multiple things, and it's like it builds on top of HTTP, DNS, JSON, WebSockets, CBOR, and I think maybe these are the ones that I know. I'm sure there are like it's like WebSocket or HTTP as the transport, and then CBOR as encoding, I think, for JSON, and then DNS for a bunch of things.
So it doesn't really like try to reinvent anything on how the internet works. It sort of builds on top of the existing transport layer of the internet.
Yeah, and it's kind of like what is, well, I guess it has a few of its own inventions. Like I would say, there's something called Lexicon, which is a JSON type definitions. So they did not go with RDF or JSON LD or whatever. I think that's what JSON schema. They made their own because none of these things quite fit what they wanted. So there are some custom pieces, but it tries, like where appropriate, it tries to reuse existing primitives. And I think, like, for example, like domains as handles is like one example where it's like instead of inventing its own handle system, it's like, well, like it has to be centralized in some sense, right? Like because somebody has to determine top level mappings, like who owns this username, and they decided, well, this already exists on the internet. It's called domains, so we're just gonna use this existing system for this. And I think like there's a lot of that in the design, and then there's also cryptography. Yeah, so the in addition to all of this stuff, there's also not in the sense of like crypto, like blockchain or whatever, even though there is like one element that is maybe reminiscent of that, but well, we can get to that if we want to. But overall, it's much more like the web, but there is, there are cryptographic signatures and like public key, private key cryptography.
The math part of cryptography.
Yeah.
So whereas HTTP has so HTTP and ATProto both have URIs. And for HTTP, everyone in the web world knows it's URLs. You have like a domain that maps to a server, and the DNS helps resolve the path to the server. But in the ATProto world, what is the common URI? What is in there?
Yeah. So in ATProto, all URIs, like first, it's worth, just like we're talking about at URIs, right? So it's like at colon / and then like what all goes after it. So I think the first question is just like, well, what does it point to, right? Like HTTP URI, like it can point at a a song or an image or an HTML page or something like this, and then like maybe this is point at records, and a record is a piece of JSON with a typed schema. But a record essentially, like ATProto, is like every at URI points at some JSON, something you like. For example, a Bluesky post is a piece of JSON. A Tangled, this GitHub alternative, Tangled star, you can star a repository there. Like a star is also a piece of JSON. A Bluesky follow, if you follow somebody, then that's a piece of JSON that says you follow this person, right? So it's the stuff that you kind of create, these like documents or records through the apps. And then these records can link to each other. That is kind of the big idea, is that, for example, if I comment on your post, each of us has this like folder or like a repo where all of our stuff lives. But the important part is you have yours and I have mine. So that is kind of the big idea also, that we like each of us owns just our own data. And sure, maybe we use some hosting for that, like behind the scenes, right? Like when I sign up for Bluesky, I don't think about like where it lives, but I actually moved the hosting, so like you can move it over time. And so all my stuff is in my repo, and all your stuff is in your repo, right? And for example, if I, if 10,000, I'm going to give you actually a test to see if you understand it. So if 10,000 people follow you, where do these follow records live? Are they in your repo or are they somewhere else?
I would say they are distributed across like 10,000 users,
Yeah.
right? Because everyone holds their own follow state.
Exactly. So if you have 1 million followers, they're not actually yours. They're one follow record per each person who follows you. But then if you follow 1 million people, actually that's 1 million records in your repo because it was like your choice to follow them. So now that we kind of understand that your stuff lives in your repo, my stuff lives in mine, if I comment on your posts, that's like a comment record in my repo that has a link to posts in your repo. And that's where like @URIs come up, is I need a way to link to something that exists in your repo, to some piece of JSON. And so we kind of have this like web of JSON where instead of HTML pages with links, we have JSON with links. But that is where the need for actually like for a separate protocol comes up and why we have it. Because if we just use HTTP, like imagine that there is some server hosting you, like your hosting company.com slash you slash like your post, and I just link to that from my repo. That means that you can never change the hosting company without breaking the link. So that is right. Like it's kind of like we have the domain system which lets whoever hosts the content change where it's hosted, like change IP address, but it doesn't let you, like there's no way for you to decide to like move off of that thing without breaking the links, because it's it's hosted by some hosting company.com, so that link will break if you move away. And from like a product design perspective, like that is the big reason why everything went wrong, which is if we put stuff into these apps or into these boxes, and then it stays there because we can't like they have power over us. And so coming back to your question, like what is in the app protocol, you have like it also starts with domain authority. So it kind of looks, you may see like on colon slash Dan Abramov, danabra.mov is my domain slash and then like it will be like Bluesky post or something slash and then ID of that post. But the important part is that the first thing is actually not where it's not where it's hosted. So it's not the physical server. It's not the domain for the physical server. It's my username in a sense. And so there is an extra resolution step where we find out, okay, for this username, where is the current server where this is hosted? And then it goes to HTTP to get it. So it's kind of like one indirection that lets it kind of puts like usernames before the physical storage, and that lets me over time I can change where my actual hosting is, and none of the links will break. So that is kind of the big motivation for why it's done this way.
So if I rephrase this in my words, the issue with HTTP is that it uses URLs, and URLs are pointing at locations. And the issue is that those locations are a matter that can change. So they're like sort of ephemeral. But ATProto says we somehow need this to never change, to have some resource identifier that will always point at your repo.
Yeah.
Okay.
Or you could say that it kind of puts people first, like literally, because the authority part of the URL is the physical host or the location, and then in @URI, which is there's like a tangent about like it being URI or not, but essentially the authority part is the user themselves. So it's not like Bluesky slash me slash Bluesky slash something. It's like it inverts the relationship so that the user comes first. And there's a nuance that I just wanted to flag, that like the first part, like we talk about like the username, that's kind of the friendly way to write in that URI, but it's actually also unstable because you can change your username over time. So there's a kind of the full form of a URI. It starts with something called a did, which is just a permanent identifier that never changes. So this is the thing that's like forever immutable as long as you're in control of your identity.
Okay, I want to come back to the did part because I think it's really important. I didn't know it was pronounced did, no pun intended. But so to get this back to the HTTP discussion, in HTTP, you would have a domain, which there's a matter where you could perhaps lose access to your domain. And the domain sort of allows you to obfuscate where your data actually lives. But you could lose the domain, and that's the issue. And to solve that, the ATProto adds a different layer that says, no, the domain or your server is not what we're looking for. The identity is what we're looking for. And if we have your identity, we can resolve that to where you host.
Yes, I wouldn't say that it's because you can lose, although certainly you can lose the domain, but I think it's more about if we're talking about something like a tweet, right? Like it's not gonna live on your domain anyway. Like it lives on on Twitter. So if we try to design this thing with HTTP, then the HTTP URI would be like twitter.com or like Twitter datastorage.com or whatever, right? But then the problem is you can't walk away from Twitter now and use a different app without, like, you can't get rid of Twitter without breaking all these links. So it's more about that you're like when we hosted our content ourselves, like when each of us had a site, right? We were directly connected to how the internet works. Because if we don't like the hosting, we just change our hosting, but our users don't need to know. They still go to our site, it still resolves. But when we moved into social spaces like Facebook or Twitter or Stack Overflow, we're now one step disconnected from how the internet actually works because we can't change our hosting. Like you can't change your hosting when you're using Twitter, right? Like Twitter couples the app and the hosting. And so the idea here is actually let's still make your content live in a different world where you can change the hosting and it's app agnostic. And the app is just one of the consumers of of this like a layer of the internet. Like in that sense, I kind of like to think about it as similar to RSS and Google Reader, right? Like you control your RSS, you can move, like where you host it and so on, but then you can consume all of the RSS you're interested in from apps such as Google Reader, but they actually have no sway on the, on the underlying system. Like if Google Reader disappears, somebody else can make an RSS client that reads from all of them. So it's about avoiding lock-in, really. It's not so much about like it's about removing the power from the apps to kind of keep you locked down.
That's a really nice way of putting it. And now that we know the promise of the ATProto, I kind of want to dive into how it works. So you said there's like this did that can be resolved to your identity. For HTTP, the domain would be resolved to your location via the DNS server. You do a DNS lookup and you get the IP address. How is the DID or did resolved to you?
Yeah, so let's first start with what a did is. So this is kind of it's a W3C standard. So they try to reuse like this part. But it's kind of a meta standard in the sense that it doesn't actually specify how to resolve a did. It's more like a did is a format where first it says like did colon, and then there's something called did method. So this can be, like I think it's maybe 3 letters, or maybe it can be more. But it's kind of like the method actually specifies how to find a certain thing, like a piece of JSON that's your identity, but it's method specific. And then from that point, like the rest is identifier for this method. So it's almost like a did is just kind of a universal let's make many ID systems under one umbrella. And then ATProto picks 2 ID systems supported by did. because they satisfy certain properties, right? Like on property, you want it to be, kind of fast to resolve, right? So something like, I don't know, download all the blockchain and whatever. Like that's already like a non-starter. Like it has to be something that's like easily resolvable. It has to like I don't remember the exact properties, but they basically picked two things, and one is the one that they invented. So there are two did methods supported by ATProto. One is called did.plc, which initially stood for placeholder because they thought they're gonna
Oh,
replace it, and then they thought actually it's quite good. We're gonna keep it. So one is PLC. Now it's supposedly public ledger of credentials.
okay.
Um,
That's crypto like ledger. I
yeah,
hear a
well,
crypto word.
I think that is an influence from that world. I think, yes. But it is not. It's actually not distributed. This is the part that's like centralized. It's kind of like an npm registry. Um, and the other did method is did.web, which uses just a normal domain lookup. So these are kind of like two ways this can work. In both cases, the goal is to resolve to a piece of JSON that is called your did document, which I kind of like to think as a passport. It's like it's a piece of JSON that says three things. One is where your stuff currently lives, so your hosting, your like HTTP hosting. Another is what is your handle, so that's your like domain username. It can be completely different from like where it's hosted. These are completely unrelated. And the third thing is what is your public key. So if somebody wants to verify some some record or whatever, what is the public key that they verify against? And so, but yeah, these are like two methods, and the difference between them is one is more centralized. They're like legally they're kind of spinning it off into like a Swiss organization that's going to be independent, and like the idea like it's kind of like the goal is for it to kind of evolve similar to how top like root DNS has evolved
Mhm.
with like ICANN and like some kind of thing like being managed like neutrally. But it's like being centralized is kind of the point, because that is the authoritative place to say who, what's under this identity. But they came up with a bunch of things that kind of make it less of a problem that it's centralized. So, for example, it's like it's entirely open source. There is no private state in it, so like it's actually like fully kind of replayable just based on public data. You can like audit it. Like there's an audit log. You can change in every transaction and so on. So it's like highly auditable, but it is essential thing. And so that's kind of the usual way. Like if you sign up on Bluesky, you're gonna get a PLC identity, and then PLC is the thing that holds your like did passport or like did document. But if you like hate the idea of like anything centralized, there's did web, where your username after that is literally like the identifier part is literally a domain, instead of like in did PLC. In did PLC you get a hash. In did web you get a domain, but then if you lose the domain, they actually you can't control it anymore. Like it dies. So that's kind of the choice for like hardcore decentralizers.
So PSC directory is the centralized place to look up bits that use the method of PLC. And
Yes.
public ledger sort of implies that there is like a way I can look up the ledger and see that like first I can see what happened on the ledger, and public means that probably everyone can look it up. Can I just go and like do a HTTP request somewhere and get like
Yeah.
info about my
Yeah.
PID?
There is something called the directory. Is
Mhm.
I think the the website. It has an example where did resolution can be as simple as curl -s http plc directory /did, and then that gives you your JSON. So there's kind of an API there. There's also API for like curling like the past versions. So you can see like for every did document, what does it say now? What has it said in the past? You can verify that each change is signed by a key that is like the public key of the previous version of the did document. So you can kind of verify like that independently verify that the document could not have been fudged because it's signed by the user's private key, which the PLC registry doesn't have. And then the first version of the G document, when hashed, that hash is the is your identifier on PLC.
Mm-hmm.
So you can verify that the first version is also correct because it's also like it has the signature. So it's like a hash of the signed version of the first document. So you can recursively verify for every user the entire chain of changes to their identity, including changes to hosting, to the key pair, and to the username.
So it's a cryptographically verifiable chain of events of what happened to your passport, so to say.
Yes.
With
Yes.
no loose ends, because the first entry is the did yourself, the identifier yourself. Okay,
Yeah.
very cool.
Yeah.
And you said there's like 3 parts living in there. There's your alias.
Mm-hmm.
There's the part where your data lives. And then what was the last part?
The public key.
The public key. Okay, so people can verify that it's actually what it claims to be. So so where does the data actually live? Like what would be in my did document? The ID document.
So for example, it depends on how you made your ATProto, like we call it the atmosphere, like this layer above the web. This is like atmosphere, right? Like ATProto. So it's kind of like, it's so having like an atmosphere account. It's kind of like having Google account, except it's the web, right? Like in a sense, it's like the web account. I think that is like part of the idea is like that we just all have these web accounts instead of accounts that are tied to a specific provider like Google. And if you follow the document, it will say, for example, if I sign up on that product through Bluesky app, it will have to create hosting for me, right? Because I don't have a hosting that already exists. So the Bluesky is kind of 2 different things actually. There's Bluesky hosting, like under the hood, right? And there's Bluesky app, and they're completely independent. So I changed my hosting to a different provider. Actually, you can also self-host, so you can run the server yourself. It's it's really cheap. But this hosting part if you sign up for Bluesky, it's gonna say something like, some server dot bluesky.network or whatever. And so this is the server that will host your JSON that contains your private key, and that is able to serve, your if like apps want to know like what you have posted, it can serve your posts, or all the other information from other Atmosphere apps. And it also provides a WebSocket connection for notifying about changes. And that is why this whole thing works real time, right? So it's not kind of just like pull. It's more like apps can subscribe to your hosting, and then they're notified when something comes out, so they can immediately ingest it and put it into their databases.
So for traditional web, this would be, for example, the Twitter server. I want to post something to Twitter, and it goes to the Twitter server. But in AppProto web, this is the PDS part, right? Personal data server.
Yes, yes.
And my data only lives on one server. So it's like a one-to-one mapping of my...
Yeah. Your data is always points to one. I mean, one server can serve many users' data, right? So it scales, but your own stuff only lives in one place. Yes, this is like the source of truth, right? Like then the apps, of course, will consume it, and then they have their local caches or databases and so on. But it's kind of like the source of truth is your PDS. Yes.
So I think I'm on the same PDS as you. I'm German, and I moved to eurosky.social.
Yeah,
I think that's a PDS. And I did like a migration and everything. And I think that's the interesting part you talked about earlier. Like since your identity stays in one place, you can like switch where your data lives, and like everything follows it around. So I had like a Bluesky account, and that I think initially signing up there left me with the default Bluesky PDS. And then
Yeah.
I did a bunch of posts, a bunch of likes. I followed, of course, Dan Abramov on Bluesky. And then at some point, I wanted to move that to Europe. And what happened behind the scenes there when I did the move or like the migration?
Yeah, so the first thing that happened is like all of your JSON has your repository. It's kind of like pushing if you're familiar with Git, it's kind of like pushing Git to a different remote. Like I think that's what it is. Like your repository has been pushed to like another place. And then the last thing was like once it was like you also had to I think like migrating media is currently kind of wonky. Like you have to use a separate tool to get all the image files migrated, which was a bit weird. But like I think they're planning to like improve on this so that the actual migration goes server to server. Because I think currently it goes like server to client to server, which is why it's like so strange. But like ideally it would be like much faster and kind of smoother process. But then once that repository appears on the other server, the last thing that happens is you submit a change to the PLC registry, right? So there is a request that says update my passport or my JIT document to say now this is my hosting. Now this is where this is the HTTP endpoint where my content actually lives. And so that is the last part. And then that change is going to be broadcasted from PLC. So apps, I believe I don't think I have an audit log, but I think that I think the dominant model is just that apps cache identities over like 5 minutes or like hour or whatever. So like later, like next time they try to resolve your did, they'll be like, oh, like okay, the content is hosted somewhere else. But for most apps, they don't even need to do anything because they've already cached all the data by its at URI, and the at URIs did not change. So it's like, well, who cares that like if they need to refetch it for some reason, they can go to your new server. But really, like for apps, it doesn't even matter because it's like most apps, well, I guess many apps just cache stuff.
So basically what I did, I had like a repo with all my data and I had that on GitHub. And then I did a Git clone, pushed it to GitLab instead and deleted the old repo on GitHub. And then updated my passport to say, hey, my data now lives on a different GitHub.
Yeah.
Okay, that makes sense.
Yeah.
And in this repo, like what you said, there's like a bunch of JSON living in the repo. But what exactly, what kinds of JSON are there?
Yeah, there's actually a great tool to inspect it. So there's something called pds.ls. So if you literally type PDS as in personal data server .ls, ls as in Unix ls utility, for listing files, is going to give you this like thing where you can input any ATProto handle. So you can input your domain if you have a ATProto account associated with it. And it's just going to show you the whole repository. So it's going to show you there's like collections, which are kind of like folders. Yeah, like if you search for the number or like for yourself. So now it resolves the did, it resolves the, you see, like now it says Eurosky social, so it resolves where your host actually lives. And then these collections are kind of like folders. So they're grouped by type. So these are all like kind of different types of JSON. And they're app specific, right? So like Bluesky app has their types, and then npmx has its own types and so on. So like every app developer, you can come up with your own. Like nobody is kind of policing them, so anyone can. But they're sorted by reverse domain, which kind of gives you them unique prefixes like naturally. So like if you work on some app, you just put your app's domain there. It's kind of like your namespace, kind of like scoped packages on npm almost. And then if you go into any folder, you're going to see a list of JSON files or like records in that folder that all have the same type. And it's just normal JSON. So it's just like a like would be a JSON object that says which post was liked, for example. And these are going to be links. So if you click into like a like and click into any specific piece of JSON, there's actually going to be like specific, like for example, this is a like for a certain post, and if you follow the link to the post, you might end up on like a different person's repository with the actual post.
Okay, so for the people listening to this podcast, I just navigated to pds.ls, and then I put my alias, so my email, my domain, theosteiner.de on there, and that sort of did the did lookup. Is that how you call it? The PLC lookup.
Yeah.
And it found my PDS, which in this case is eurosky.social. And below that, we had like a bunch of records. No, wait, a bunch of collections. And the collections are all of a certain type, I'd say. And the type is like a reverse domain identifier. So for Bluesky likes, it is app.bluesky.feed.like. And if I click on that, I get all the likes I ever did on Bluesky. And if I click even deeper into that, I get the actual JSON. And here it says, so it has a timestamp, a created app, and then it has like a subject, which I assume is the...
Yeah, there's the post you liked.
Why does it have a URI and a CID? So URI is the thing we talked about earlier. This will resolve to somebody else's did document, and then from there we can get the PDS, and from there we can get the collection, and from there we can get the entry, the post of the collection. But what is the CID here?
Yeah, CID, it's so there are like two types of links in ATProto. One is kind of like a weak link, or like just, I think it's called a ref, which is just a normal at URI. And then another one is called a strong link, which is URI and CID. And CID is just a hash of the linked record. So the idea is like, if for some links you maybe want to, like, you want the apps to be able to tell, is the thing that it relates to the same as it was when, for example, like for the like if the post was edited, does that still count? And I think Bluesky app actually doesn't. I don't know. I don't think it reflects edits. Like, I'm not sure. Like, I think maybe it doesn't. So this is like application's choice to kind of disregard edits, or it's like a product decision. But if they ever allowed edits, this would allow to say, was your like on the one that's there now, or has it changed since the like?
Okay, so if, for example, I liked the post that said tabs are better than spaces, and then at some point the editor, the poster, the author of the post went back and said spaces are better than tabs, I can point at this record and say, no, because the hash changed. Back when I liked it, it was a different post. Okay.
Yeah.
And what is the dollar type field here in the JSON?
Yeah, so this is the name of the collection it's in. It's kind of a convention that it's just always going to be there. So it lets you tell just from the record what kind of record it is without looking, without even knowing the URI. So it's just the folder name, the same thing.
So a like would have a very different data structure to, let's say, a post. How does Bluesky know how to parse those records?
Yeah, so this is an interesting question. It's kind of like you can optionally publish. Well, there's something called lexicons, which are kind of like type definitions. Like, I really think of them as a lexicon. There's for each of these types, like a Bluesky like, Bluesky post, Tangled, whatever. Like, each of these things has a schema associated with it, written as JSON. And actually, the funny thing is, you don't have to publish them. So it's only it's useful for apps, because apps, there's like tooling that generates like actual parsing code and like validation, or like Zod validation, or so that you can safely read it into like a typed form in any language. Like, there's for JavaScript or Swift and Go and so on. Like, there's there's like a code gen libraries that do this from lexicons. So that's why. But the thing is, you can also publish lexicons, and the funny thing is, the way you publish them is they're also records. So you can publish a record with the with the type definition, and actually in PDSls, if the record is in, so if the type is published, you can actually click on it as a link and it will show the record. So if you like in that on the screen that you were showing where you had the like record and it says type colon dot feed dot like, if you press on it, there's like a lexicon resolution mechanism which says how to find the record that has the schema for this type. And PDSls actually displays it like nicely as a, almost like as a documentation like format.
So this is like how they allow storing arbitrary data, because there's a way to define how data is structured, and every app gets to define this themselves.
Yes, yes. Although it's even more interesting because like I think that is kind of the starting point. As a developer, you just choose your own formats, but you can also just choose to reuse existing ones, right? Like you can decide that you're making like maybe like a plugin for Bluesky, and then you use like the Bluesky follows as a format for your thing. Or you can make maybe you're making some kind of a annotation like community notes feature or something like this. Like maybe you're making like a product. Well, in this case, like it would make sense for Bluesky to do it, but maybe you're making some kind of like annotation thing, and then you could allow the target of your annotation be like Bluesky posts or Tangled repos or like anything. You can link to anything. So in that sense, like it's like you can use other apps formats. You can kind of link to them, or you can literally like use that as your own format. And the same as like with file formats, right? Like we have many apps that use the same format. And with that's actually like there's been like precedent in there is like 3 blogging platforms on ATProto. One is called Leaflet, another Offprint, and another is called Pocket. And at some point, they actually worked together on a single lexicon because they wanted to be like more interoperable, so that subscriptions from like one show up in the other, and so on. And so they actually agreed on the format for like a publication or like a follow, and this is called standard.site. It's become like a kind of a bigger thing than this. Like it's kind of like RSS on AppView in a sense. But the funny thing is like now you can also like adopt standard.site for your own blog that's like not hosted on any of these platforms, and like create records for your describing like your posts and your publication, your like brand colors in the publication. And the funny thing is like now links to any standard.site posts on Bluesky app will be shown with like a special treatment with like a box that has the color, the branding color of your site. So this example where like 3 different blogging platforms decided to share a lexicon, and then the Bluesky app decided to read that lexicon and like to use the information from it. So in that sense, like it's a much more dynamic kind of ecosystem where like some things get kind of standardized in a sense, but completely community driven.
This is kind of wild. This is like I built my own app, and to kickstart it, I let my users post from my app to Instagram. And I let them post pictures to Instagram, and I can also display every picture they posted to Instagram. There's this moment where it kind of clicks.
Yeah. Well, the other thing is like you can index things of different types, right? So, of course, indexing, for example, like all Bluesky posts is like crazy in terms of volume, so that's expensive. But you could maybe index like something that relates to the user, and then you can do this kind of like mashups where, there's another funny example. There's this lexicon. Do you know Last.fm?
Yeah,
Like
I've heard
the
of
music tracking thing.
Yeah.
Yeah. So there's a lexicon called Teal FM Play, which is like Teal FM was like supposed to be something where you're gonna track your music usage, But then I don't think they still like it's kind of been in development for a long time, but
Mhm.
they're doing it on like weekends, so they still haven't launched the actual website or like the app. But it doesn't matter because the lexicon exists. So they already made tooling to actually submit what you're listening to, even though there is no, there's no app. It's just you're just writing records of this lexicon. And so people have already made kind of there's like third-party apps that display your listening stats on Teal FM, even though Teal FM does not exist.
Mhm.
So it's kind of funny. And like you can show like aggregations across like what are top listened artists on the way I kind of think about it is like if you had the world's JSON, like why not run joins over products,
Mhm.
right? Like you can do things like top tracks that your follows on Bluesky have been listening to, right? You can be like, what are the repositories that trending repositories from your friends or whatever. Like you can kind of combine data from different apps and cross join it, which I think is like that feels like the web to me. Like that's kind of like taking the web idea, uh, kind of like a web database. I don't know. Like it's like breaking the boundaries or like blurring the boundaries between apps and making it more like there's the web of data and then the apps are just like lenses through which we kind of look at the data,
Mhm.
and these lenses can be anyone can create a new one.
And like posting records across products sounds kind of crazy at first, but since it's the ad protocol, so it's like authenticated transfer, which means you have authenticated everything that is posted to your repo, and that's why it's safe to post across apps, right?
Yeah, so the way this works is like apps can be sure that the content is really your, because they can always like resolve it through like the ad protocol. They go to your hosting and then your hosting returns them the thing, and it is signed with the key that they can verify that that's the key in your in your registry or in your did document. And then the other clever thing that they do is um, there's of course you need to somehow scale up the network because you can imagine there's like million for each user there's a hosting. Of course, like a lot of users are going to be on the same hosting, so the hosting can be like from like hosting like to 100,000 users
Mhm.
to like maybe a solo user hosting. Like both of these are kind of valid. But that's where the data lives. But then you somehow need it to flow into all the apps, right? And like it's inconvenient for apps to, like all you don't want them to smash like all the hosting all the time to kind of figure out what happened. So like apps maintain caches and subscribe through WebSocket. But then there's a question of like, okay, how do you scale it further? Like you kind of want some shared infrastructure, right? Like you want some shared caches, you want some shared like retransmission from ideally like you want to like there should be like a way to just subscribe to WebSocket to one event bus that has that kind of multiply like it that has like information from about everything that happens on the network, or this like subset that's like relevant to your app, maybe like your app's collection types and so on. And so what the clever thing they did is that you can build, and then there are retransmitters like this that they're called relays. Like Bluesky runs one. There are like a bunch of community run relays that let you just subscribe over WebSocket to like everything that happens on the network. And then the stream that is passed is like a stream of commits, right? It's like a stream of events about commits, identity changes, and so on. And the stream is retransmitted with proofs. So the stream contains the like signed like each commit is it's like signed commits in Git, I guess. So each commit is signed. So we actually don't need to trust the retransmitter.
Mhm.
So that's kind of like another big idea is that because like cryptography is kind of like woven into it, you actually don't need to trust, like you can build community retransmitters and these nodes and kind of not have to worry that they're actually like modifying the content as it flows through them.
So
So that's the authenticated part in it.
if I try to recap this for my understanding, so you have a very weird distribution of personal data servers. There are some with millions of users, probably the Bluesky ones, and then there's like the people who host it in their basement.
Yeah.
And to not have every app know every PDS and like go there every time and pull them all the time, you have those relay services, which is, I imagine, like super beefy servers somewhere that for somehow know all PDSs and subscribe to all of them. And then it's just like a huge Apache Kafka, and they just pipe the events into the
yeah.
web.
I don't think it needs to be like super beefy. I'm not sure. Like in terms of costs, I think it's something around like $30 a month to like run it at the current volume. But yeah, it needs, and yeah, they need to know the PDSs on the network, which is a bit wonky because like, well, how do you know? There's a bunch of ways. Like one is just like, I think you can enumerate, like there's an endpoint on existing relays to like enumerate the ones that they know, I think. So that's kind of how you can bootstrap. A PDS can also request to be crawled. So a PDS can decide, like if you put a new PDS online, you can like add some known relays to kind of ping them. And then it can also discover it through links, right? So like if it sees a link to a PDS it hasn't seen, like that resolves to a PDS it hasn't seen before, it can decide to crawl it. So it's kind of up to the relay how to do it, but it's yeah, and like if it wants to just like provide an archive or to only retransmit and like have no archive, because like keeping an archive is kind of expensive.
So if I want to build on ATProto, I have this like shared data layer, and I have like apps that are already quite successful that populate that data layer with users, and those users use those apps and therefore populate it with their own records.
Yeah.
And if I want to build on that, I would probably get one of those relays and just like start downloading data from there and like putting it into my own database. Is that how it works? And then run queries and my app logic on that.
Yeah, so I think this the exact way you do it depends on what data your app is going to care about, right? Because if it only cares about its own data, like if you you came up with new record types and you want to just, that's the stuff that your app displays, then you don't need to backfill it because it doesn't exist. So, if you just connect, you just start listening to like a relay, and you filter it down to the stuff that like your app cares about, then once records start getting created, you will have all of them. So you don't actually need to like get anything that exists before, right? And that's kind of the easy path. And then you just have a connection to this thing and you keep track of like, if like you want to do something with existing data, then you have to backfill it. So you have to, well, there's really kind of two ways to go about it. Like the way I'm telling about is, if you want data to be in your own database, then of course you have to somehow get it there, right? And then the question is like, okay, is it from a big app or like a small app? Because if it's something like Tangled, you can probably backfill, all records from all Tangled users in like a reasonable time, because there's just like not that much, right? Like maybe, I don't know, maybe like 50,000 records. Like I don't know how many, but it's not that much. Or like Teal FM, okay, maybe a lot of records because people do scrabble. It's like probably millions now. But essentially, you just need to find like all the. I think maybe Relay has an API for this, but there's like a way to find out which users or like which identities have collection of a certain type. So you can kind of figure out who are the users of a particular app and then just get their stuff. And so there are tools that do this. There's like something called Tap, which is their tool for backfill. You tell it which collections to kind of look for, and it will, try to synchronize it all, and then kind of listen to the new events. But there's also like a different approach, which is, especially like if you want to like Bluesky, yeah, you probably don't want to download like terabytes of all Bluesky posts that ever existed. But maybe you want to build some app on top of Bluesky. Of course, you can use Bluesky API. That's kind of the traditional way, but then I think it's a bit like not ATProto spirited, right? Like, well, you rely on somebody else's thing that's like app specific. But there's a tool called Constellation. It's community run. It's like a server run by community that indexes like all the records and provides an API for backlinks. So it lets you say, given this post, give me all the records that link to it, which means like that you can get like all the likes of a post, you can get all followers of a person, you can get like all quotes. It's kind of like just going through the primary foreign key kind of query. You just like, what are all the things that link to this piece of JSON? And so this actually lets you like build a workable app without the backend even, because you can kind of just hit like you can hit the user's hosting if you need something user specific, and then you can hit Constellation if you need to kind of go one step, removed and see like all the things that this links to. So this is less efficient, but you don't need to backend it all then.
Yeah. So the more I hear about this, at first I thought like this app protocol is really complicated, but now I understand why it needs to be complicated, because it collapses the stack. So my app needs less and less. It doesn't need a data layer necessarily, because every user has their own data layer, and I can use the existing relays and everything to aggregate that. Then it doesn't need like a authentication layer, because the user has, is it called an Atmosphere account?
So it uses OAuth, right? So you log in through OAuth, but the OAuth provider is actually your PDS. So in a sense, it's almost like logging into Google account, except you are the Google, like you're hosting, and then you can So this is why like if you change the URI, when you click like login through like Atmosphere in like other apps, it's going to show the URI's login page now, because that is now your hosting.
The domain is eurosky.social, and that's where I log in.
Yeah.
Super interesting.
Yeah, so it's kind of lifting identity and the data. Like I think of it as that's the data layer, like people-centric data layer for the web.
That sort of also brings its own complexity though, right? For example, if you have like, let's just take Instagram, an Instagram competitor, and you want to build that app, and it's slow, and you want to debug or like improve performance. But the problem could be outside of your product. It could be the user's PDS being really slow or like laggy. It could be the relay struggling to aggregate the data. How do people cope with that?
Yeah, I think like with hosting itself, it's kind of pretty resilient. Like the idea is pretty resilient. I think if you want a good app, you just shouldn't really go to hosting much, because you aggregate things as they come in. So the hosting just emits events, but like you shouldn't blast the hosting with like 1,000 requests. You just serve everything from from your database or from the stuff that you've cached. So hosting being a bit like wonky is actually fine, as long as it actually emits the events that it should generate. So that isn't really like a major problem. I think it's just a server that serves some JSON. It's so it shouldn't really get laggy. Of course, like yes, for users who are, for example, on Bluesky PDSs, and then Bluesky is having like scaling issues, then in that case that does reflect in the app, right? Like some events like struggling to come through, like the relay struggles to come through. I think in terms of like this is something that you just kind of live with. It's your app is more webby. There's more things that could go wrong. The itself, again, if you rely on like the Bluesky, the one run by Bluesky, it's mostly working fine. I think there's been sometimes incidents, but it's mostly working fine. But if you don't trust it, you can definitely run your own. And then like if that is how you like completely kind of like isolate yourself from problems with like upstream, I think like there's like that there were also cases where like other apps that ran their own relays or like used the community relay were up when like the Bluesky app was not working because there was like some relay problem. So I think like with time, as there's, I think like now is like the early adopter stage where you run it because you believe that there's just a better way to kind of do web, like web products. But like I think of it as like open source in the 90s. Like if like people would tell you you're crazy, or that like Microsoft is like says it's cancer, and then like 10 years later like Microsoft is actually like running on open source. So I think like now is that stage where people tell you you're crazy, and so this is like it is yeah, like it's like early adopter pains. But because I think because it's a standard, it's kind of like every, like I think everything that like benefits like some apps can like benefit others because they kind of speak the same language. So there's like shared infrastructure like Constellation, shared like libraries, tools, like different kind of things you can do with it. So I think like as that infrastructure grows and is more reusable, there will just be more like the network will be more resilient in general, because there will be just like more options with relays and more things you could, it would be like easier to backfill. There would be like archives for just like rehydrating everything if you like lost some data or whatever. So I think we'll see more of that.
Yeah, I actually just thought of a really interesting problem concerning sustainability while you talked about Bluesky being both the app layer and the PDS layer in their case. Because for Bluesky, like I would clearly see a path to monetization. They have the app layer, and it would be quite easy for them to monetize that. Let's say put display ads on there or have like premium accounts. But like there are PDSs who don't have an app layer, and they have the cost. I'd say they bear most of the cost because they have the egress and the hosting cost, right?
Mhm.
But how is there like a way for apps to give back to the PDSs, or like to sort of shift the weight of the cost structure?
Yeah, I'm not sure. Like, I think running an app is like many times more expensive than running hosting. I'm not 100% sure, but like first, like the scale of the app is open to serves the users, right? So if you have like a million daily users, then that's the load that goes into the app, and then the hosting serves the apps. So that's actually like different hosts. Then if you self-host, you really only serve your own data. Like it doesn't, it's not really um like it doesn't put much like compared to something like Mastodon, where like if your post goes viral, like all the instances are gonna hammer your instance to whereas like here it's actually like it doesn't really matter that much because the app shields you. But the other thing is like I think hosting has maybe, I think part of it is just like people don't really, it's such a novel concept that you have a hosting as a user, right? Like that's usually like you have a hosting if you have a website or like a company, but just as part of your internet experience, even though like you like log in with a Google account, that's kind of the relationship you have to Google maybe. But the idea is that we can kind of lift this up and make it transferable. I think it's kind of new, right? That like there's like a Dropbox with all your social data. Like that's kind of new. So I think it's not even like recognized exactly like by the mainstream user at this moment. Like maybe in 5 years or like maybe in 10 years it would be. Um, but you can also like offer, there could be like services that the hosting offers, right? So like I would actually like pay for just like safe backups, right? Like I would really want my hosting to just periodically back up all my data without me thinking about it. Like that could be like one thing. Some people want like more storage, maybe for like videos and stuff like that. That could also be a thing. Um, but in general, I think it's actually the app that is much more like because things like CD, like transcode and video, like all of that's like serving a lot of video, like all of that stuff is, I think, way more expensive than kind of serving JSON. So that is where I think like a lot of the costs actually go.
So you're saying sort of in order to run a stable app, you want to shield the PDSs from your app layer anyways, and shielding the PDSs will take most of the load off the PDSs onto your app layer. So it's sort of a like self-restraining system.
Yeah, because you don't want it to, you want it to be reliable, and so you don't want to be like, if a PDS is misbehaving, like you don't want it to reflect on the app. And also, like, you just kind of have to like past a certain level of product complexity. You just have to have a database, or like you can hit community caches, but then they're shielding you, right? So if you hit Constellation, that also shields hosting, because Constellation has a cache of like everything that's that it has indexed.
Interesting. So what would you say is currently still missing from the ad protocol? Is there something that's not here yet?
Yeah, I mean, there's a lot of rough edges just in terms of developer experience, or kind of what is the right way to do something. Like it's still kind of being debated. Like some things are like people are experimenting with. But I think the big thing that like the team is, that product team is currently working on is permissioned data, because currently ATProto is fully focused on public data, which I think was the right focus in terms of like actually proving out that, like, if you start with private, that's a smaller scale, you don't know that you're going to scale up to public. Whereas if you scale up to public, you have to figure out how to do aggregation, all these things efficiently, and then you can kind of scale down to permissioned. But they're working on extending the protocol, or like having like a sibling protocol for stuff that is not meant for public retransmission, such as groups, like not like messaging, because you just want identity still, but it's like a separate thing. Whereas like things that are kind of gated by like a membership, they're not like completely private, because like any app that has been granted access, like of course we'll see them because it needs to display them. But they're basically working on this permissioned data extension to the protocol, because right now, if you want something like private or like group private, you can sort of do it, but of course with your own database. So you're kind of, which is also okay. Like AppView is pragmatic in the sense that you can adopt just the parts that make sense to you. So you can just use the identity layer and nothing else, right? And keep everything in your database. But like ideally, you would kind of move towards like further refine it a bit more. But then you run into the wall where all the like group level stuff, or like user preferences and stuff like this, like you kind of have to store them. There's like a hacky thing that I think you can store like it in Bluesky preferences. But anyway, there's like no good API for private or protected stuff. And so that's what they're working on. I think that's like a big gap, that it doesn't, there is like no way to do that now that's protocol native.
So this might be a sacrilege in a podcast with a React core member, but I'm a huge fan of Svelte, and there's like in the ATProto world, like quite a few apps seem to be built with Svelte, and there's like someone or like a group of people trying to build a Discord clone based on ATProto. I think it's called
Yes.
And they seem to be stuck on having like private servers because they don't have permission data yet. But like having permission data would unlock that for them, because they could have some data being gated behind access controls, authorization.
Yeah, probably. I think so. I think like things like chats are kind of, it's just like a different modality, because they're kind of ephemeral in a sense. I guess maybe for Discord, like you do want to keep it, but I don't know that you want to necessarily like have every chat message be a record. Like I don't know if that makes sense. But there's definitely, I think like having permission data would like help. But yeah, like Svelte is really popular in the product community. I don't know why for sure. I think it's just maybe like fits the ethos. It's kind of like webby. Also, it has these connotations of like, it's the kind of the lighter thing or like the newer thing, and like React is like Java to these people, which is like, okay, I'll take it. Whatever, well, whatever works. I think
It might just be a function of Svelte adopters being early adopters, and
maybe,
then
yeah,
this guy also
yeah,
being quite early, or like ATProto
yeah,
being early.
yeah. But I think a lot of it is aesthetic. It's just like it feels webby, and like ATProto is also very webby. So I think there's like a match there.
Okay, I think we covered so much ground in this episode. Is there anything that's like left to say? Anything that we haven't covered yet?
I would just say I think like I don't know. I would encourage more people to like try Bluesky for real, like for what you would normally post on Twitter. It's one thing I would encourage is to actually like the default feed is I think called Discover is I think not very good. Uh, there is a very good custom feed called For You. Literally like For You in Twitter. That if you go to the Feeds tab in Bluesky app and search For You, you will find it. I highly recommend it. It learns from your likes and like what the people who have liked the same things as you liked have also liked. And it's actually like I just feel like it's kind of like as good as like Twitter algorithm like used to be. So I'm just like I always use that feed. But the other funny thing is that this feed runs literally from somebody's gaming computer at home. So there's some guy who's like again like because what is a feed? It's just a HTTP service that returns an array of URIs
Mm-hmm.
for posts, right? Like and because like posts, everything in the network is identified by @URI, it doesn't matter where it's hosted. You can build these like services that understand, they're talking about the same thing. So like this For You feed, it just returns an array of @URI and like paginates through them, and then the Bluesky app server, like it talks to this feed, gets the URIs, and then hydrates them from the database into actual posts. So just think like it's very cool that like you can have like userland feeds on Bluesky, and this is I think the best one. So definitely like if you're especially if you're like getting people to move, like trying it out, just tell them all to install the For You feed because it's just better.
I'm also on For You, and it's super super funny because like sometimes the person who hosts it, like the feed goes down for an hour and then it goes back up, and he posts like, sorry, I had to upgrade my PC. I put more RAM into my PC or something. It's
Yeah,
very
yeah, yeah.
cool.
Yeah.
Okay, I think that's it for today then. Uh, thank you so much for coming on and talking about AppProto. I mean, you obviously couldn't say it yourself, but probably the best way to learn about AppProto is your blog, I would say. You have like a whole series of blog posts on AppProto and how it works, using different ways to break it down. I think the file system one is great. And then go on Bluesky and just start following a bunch of people. My personal recommendation would be they have like what is called starter packs.
Yeah,
And
yeah.
it allows you with just like one click to follow all the people in your group of interest. So for example, I assume you would be in the React starter pack,
Yeah, probably if there is one.
which was really cool because it got me bootstrapped with like a whole bunch of likes, which I was
Oh,
really
nice.
happy about. Okay, and actually, this show is also on Bluesky, URT Inside. Or if it isn't, I will make sure that it will be on Bluesky after this post. You can always check us on the regular HTTP web. Our domain is uit-inside.linecorp.com. And then make sure to follow Dan if you don't already. And thank you so much for listening. If you want to listen to other episodes, most of them are in Japanese, but there's, I think, 3 or 4 English episodes out there. So just look for them, or maybe study Japanese, or use like a tool to translate it. Dan, thank you so much for coming on.
Thank you.
Bye-bye.